Alright, so this is the last section of this chapter, and we're going to talk a little bit more about variations, but we're going to go over inverse and combined. So the last section, in section 3, we talked about direct and joint variation. So direct was when one quantity, like the x and the y, they do the exact same thing. So they both increase or they both decrease. Joint was kind of the same way, except it was the product of a couple things. So it was like y equals your constant times x, and then also times z. Inverse and combined variations are going to look a little bit different, just because like direct and inverse mean two different things. So direct was they both did the same thing. They both increased or they both decreased. Inverse is going to be that when one increases, the other decreases. So as the years go up, the price goes down. Something like that would be an example of an inverse variation. So this could be used in a lot of different ways when you're talking about like sales of something or attendance at a sporting event or attendance at like a college or something like that. Depending on some of the other factors that are outside of those things will decide if something's increasing or decreasing. So in order to set up an inverse proportion, you're still going to have to figure out like what's your data. So what are the two things that you're trying to compare? So is it money and time, or time and like attendance somewhere, something like that. Figure out how you want to set it up, and you're going to have to arrange the other pairs so that each ratio contains like measures, and then form that proportion and cross multiply like you did in the previous sections. So let's take a look at some examples here. This first one says, if 5 machines take 12 days to complete a job, how long will it take for 8 machines to do the job? So unlike what we would have done in section 3, where we put like the machines on top and the time it took to do the job, these are inverse now. So they have to almost, it would be wise to like just set up your fractions with an equal sign in the middle. And the first piece of information, it says it takes 5 machines, 12 days. So I would put 5 either on the top or on the bottom, and then put your 12 days on the bottom of the second fraction so that they're kind of almost already cross each other. So like that. Then you're also going to do this for the second half of this problem, which says, how long is it going to take for 8 machines to do the job? So the 8 goes with the 5, and the amount of time is going to be your x, because we don't know how long it's going to take for 8 machines to do this. So then once you've got it set up, and like I said, this looks a little bit different because I didn't put like 5 over 12 and then 8 over x. I'm making them already on opposite heights because they're inverse. So we cross multiply. So we're going to do 5 times 12 equals 8 times x. 5 times 12 is 60. So we have 60 equals 8x. We divide both sides by 8. And you get 7.5, and that would be days. Okay, which should make some sense if we think about this problem. 5 machines can do it in 12 days, so if I'm adding more machines to my problem, it should take less time for them overall to do this job. So 7.5 is less than 12 days. So that kind of lets me know that it's probably correct in that I got a smaller amount of time that it's going to take for this to happen. Okay, let's do another one here. This one says that we have a 10-inch diameter gear, and it's in mesh with a 5-inch diameter gear. So these two gears, they're almost like connected to each other, but they have different diameters. That means that like across the center of that gear, it's a little bit of a different size. The larger gear is turning at 25 revolutions per minute, and we want to figure out how many revolutions per minute, or RPM, the smaller gear does. Now, since the smaller gear has a smaller diameter, it's probably turning more than the larger one would be. It's going to turn around more times than the larger gear would. So that kind of already tells me that when I get my answer, it should be bigger than that 25. So again, I'm going to set up my fractions. So I have 10 inches. That has an RPM. That's the larger one because your two diameters are 10 inches and 5 inches. So you could go ahead and put the 10 over the 5, because those are the lengths of the diameters of the gears. Now the 10-inch is the larger one, because 10 is bigger than 5. And so that has an RPM of 25. So I'm going to put 25 across from 10. I want to figure out what the RPM is for the smaller one, so that's what I'm going to call X. Then we cross multiply again. So I'm taking 10 times 25 and setting that equal to 5 times X. So 10 times 25 is 250. And I set that equal to 5X. Then I divide by 5. Anybody know what 250 divided by 5 would be? So the smaller gear is turning 50. It's making 50 revolutions per minute. That means it's turning 50 whole times in every 1 minute, while the larger one does that 25 times. Okay, so the setup for inverse is a little bit different than for direct, so you'll just have to kind of get used to that, and just know that you're putting the pieces of information that go together across from each other in your fractions. So the next thing we're going to do is solve these problems of inverse variation using the constant. So previously in the direct variation problems, your equation was y equals kx, where k was your constant. This one looks a little bit different. We have k equals x times y. So before, if I had tried to solve for k on the direct, it would have been x divided by y. So this is a little bit different here because I'm actually multiplying the two. Okay, so we're going to use that formula, or you can rewrite it again as y equals k over x. So you can use k equals xy if you're trying to find the constant. If you have the constant and you have one of the values from the, like, whatever they're giving you information about, you can actually use this setup, y equals k over x, to find the other missing piece. Remember, k is just the letter that they use to represent that constant. Okay, so let's take a look at an example here. It says that a landscaper needs a 5-person crew to complete a commercial project in 30 hours. How many hours will it take to complete the project for the following number of workers? So for 3 workers and then for 8 workers. So the first thing I want to do is figure out what's the constant. Like, how much is each person doing on this job, basically, so that I can kind of assign that to, like, all my problems going forward. So I use my k equals xy to find the constant. So 5 people would be like my x. They take 30 hours to complete a job. So that means that combined, my constant would be 150. And that would be like worker hours. So 5 people can do it in 30 hours. So if I multiply those together, that's how I got that 150. So now I can use this constant to help me find what would it take then if I only had 3 people working, or what would it take if I had 8 people working, so a little bit more than the 5. So for part A, now we're going to use the equation y equals k over x. And we already found k, that's that 150. X is going to be the number of workers that we have. So for this first one, for 3 workers, I'm going to take 150, and I'm going to divide that by 3. So what's 150 divided by 3? 50 hours. So for 3 people, it's going to take them 50 hours to complete the whole job. For B, for 8 workers, I'm still using y equals k over x. So I take that constant, 150, and I divide it by 8. You're going to get a decimal for this one. This one's not going to divide nicely. What do we get for this one? Good, 18.75 hours. Okay, so if we kind of just look at that one again, that 150, that's like figuring out how long it would take one person to do this job. So if one person had to come and do this job all by themselves, it would take them 150 hours to get it done. 5 people is 30 hours. So that's kind of like in the middle ground. So when I had fewer peoples, I expected the hours to be a little bit more, which they were. I got 50 hours for that one. When I added people, so when I got up to the 8, then that means my time should be cut off more because I've got more people doing the same amount of work. And so that's why I got that 18.75. So it all makes sense when I think about, 5 people doing 30 hours. Okay, so we're going to take this one step further now, and we're going to use this with combined variation. So we're still using the idea of an inverse variation here, but we're going to be doing combined, which means that there's going to be more than one item that we're adding, or like more than one data piece that we're looking at. So we're still going to set up kind of using that form that we saw earlier where we had y equals that k over x. That was from back up here, right here. Y equals k over x. We're still going to use this, but they're going to add like another variable in there, and that it could be just x, or it could be just like a z, or they could be squaring it, they could be cubing it. Kind of just depends on the problem. All right, so this first one is saying that z varies directly as the square of x and inversely as y. So let's just break that sentence down for a second here. So z is doing all of this stuff. Okay, I'm going to have a constant in here, so I'm going to have a k. Now it varies directly as the square of x, so that's what we did last section. Remember, direct was like y equals k times x. So z is going to be equal to k times the square of x. That would be x squared. So k times x squared. Now inversely as y means that y is on the denominator, because what z and y do are opposite. So if z increases, y decreases. So I'm putting this over y. They then go on and they start giving you some values here. They say find z when x is 8 and y is 15 and the constant of the combined variation, that's your k, is 12. So we're doing 12 times x squared. X is 8, so times 8 squared, all over y, which is 15. So 12 times 64 all over 15. Somebody do that math and tell me what you get. 12 times 64 divided by 15. Good, 51.2. Okay, we've got one more here. So we're kind of going back to hours and the amount of time it takes somebody to do something here. So it says that the number of hours, h, that it takes p persons to assemble m machines varies directly as the number of machines and inversely as the number of persons. Okay, this is a lot of words in this first sentence here. So I want to look at that first, because this is how you're going to set up your equation. So the number of hours, we're going to use h to represent hours. Okay, and it says that that varies, right here, it varies directly as the number of machines. So just like the last problem, when it said z varied directly as the square of x, so we said z equals the constant times x squared. I'm going to do my constant times the number of machines, which they're using the letter m to represent machines. Then it goes on and it says it's inversely related to the number of people, which is p. So I'm going to put this over p. Now they don't give us the constant for this one. We're actually going to have to find that first. Because it says 3 persons, so right here, 3 people can assemble 10 machines in 5 hours. So let's use this information to find our constant. So 3 persons, what letter does 3 go in for? We're talking about 3 persons. The bottom one, P. Okay, 10 machines. Where does 10 go in? Good, M. And I told you that we're solving for K, so 5 hours, 5 goes in for H. So now let's solve for K. Let's solve for the constant. So I'm going to simplify over here. It says like 10k over 3. So think about your algebra skills here. How would you guys get 3 out of that denominator? Times by 3, so I'm going to multiply by 3 on both sides. Okay, so I cross those off. Now over here on the right side, I also had to, or on the left side, I had to multiply by 3. So I have 15 equals 10k. Then what did we do? What do we do to get k by itself? How do you get rid of that 10? Good, divide. So what's 15 divided by 10? Just move your decimal. 1.5. Okay, so there's your constant. Now we're not quite done because I haven't highlighted the rest of our problem here. Okay, so let's finish reading what it says. How many people or persons would it take to assemble 36 machines in 8 hours? So the 1.5, that's talking about like how long it would take for one person to do this job. For one person to do a whole machine by themselves, it would take them 1.5 hours to get that done. What I'm trying to find out now is how many people is it going to take to assemble 36 machines in 8 hours? So I still want you guys to use this equation right here. But now let's plug in the information from the problem I have highlighted in orange now. How many persons? So which letter am I going to be solving for if they're asking how many persons? H, K, M, or P? P. So 36 machines. 36 goes in for what letter? Good, M. Okay, so 36 goes in for M. What goes in for K? $1.5. That's why you did all that work. Okay, then it also said 8 hours. So 8 goes in for H. P is on the bottom. That's what we're trying to solve for here. So can you guys, somebody, take 1.5 times 36 and tell me what that is? $54. Okay, I want to solve for P. So just like up above, when I had to get 3 out of the denominator, let's get P out for now. So I'm going to multiply both sides by P. I'm not necessarily solving it yet. I'm just moving P to a different spot so that I'm getting rid of that fraction. So I have 8P equals 54. How do I solve this problem now? Divide by 8. So what's 54 divided by 8? 6.75. Okay, now we're talking about people here. Okay, so we probably want to round up to 7 people to get this job in enough time. Because if I round down, they're not going to quite finish it in the amount of time that they've given me. They want it to take 8 hours. If I don't have 7 people, they're not going to finish in 8 hours. They're going to need more than 8 hours. Now, 7 people, they might actually get it done before 8 hours and have a little bit of extra time left over. Because I would need 6.75 people to get it done in 8 hours. Well, I can't have 3/4 of a person. Okay, so it's impossible for that to actually happen. So I either need a little bit more time, which means I could have less people, or I need to have more people and it's going to take them a shorter amount of time.